1, y equals x squared minus x minus 1 and 3x minus y equals 4. We have a non-linear system of equations. Hopefully we recognize this as being a parabola, y to the first, x to the second. It's an upward turning parabola, so it's going to be doing something like that. Y equals, and if I move the y over in the 4, which y equals 3x minus 4, that's just a line, kind of a steep slope. So a couple points of intersection is expected. No graphing required to do this, but just if you get an idea beforehand of what they look like, sometimes helps us to get an idea of what types of answers we're looking for. The one thing to look for nonlinear systems of equations is what technique can you use. Substitution tends to work every single time, where elimination sometimes works, sometimes doesn't. Substitution works when the variable types match exactly. So x to the first, y to the first, x to the first, y to the first, x squared. So that x squared messes up the thing for elimination, so we can't use that. So I'm going to be using substitution. And I can either get this to say y equals, I can get that to say y equals, which it already does. So let's just go with that. So this expression is what y equals, and there's a y right here, so I'm just going to throw that right there. I'm replacing a single object y with multiple objects x squared minus x minus 1. So when I substitute, I do put parentheses, so 3x minus parentheses x squared minus x minus 1 equals 4. Next thing I want to do is distribute that minus sign through the parentheses, so I'm going to get 3x. It's going to be minus x squared, minus minus x is plus x, and minus minus 1 is plus 1. And now, since it's a quadratic equation, I want to get everything equal to 0. My board's very well aligned. I'll figure it out. So I'm going to get everything equal to 0, so I'm going to move everything to the right because I like x squared to be positive. So I'm going to move x squared over, becomes plus x squared. X plus 3x is a total of 4x. I'm going to do minus 4x and minus 1. So altogether I get 0 on the left-hand side equals x squared minus 4x plus 3. And that quadratic equation is either going to be factorable or not. If it is factorable, that's usually the quickest way to the answer. If it's not, then the quadratic formula is probably your best bet. I'm noticing x minus 1 and x minus 3 as a factored form. Negative 3 times negative 1 and negative 3 plus negative 1 make the two numbers we have in our quadratic, since we have a 1x squared that's legal. And if x minus 1 times x minus 3 equals 0, we simply make the zeros here, so 1 minus 1 and 3 minus 3, so 1 and 3 is what x is. And once I know what x is, for each x I need to find a y. So x equals 1, x equals 3. Alright, so I can go either place. I'm going to go here since that's where I substituted from. If I put 1 in place of the x here, so I'm going to get y equals 1 squared, which is 1, minus x, which is 1, minus 1. That adds a negative 1. If I put 3 in, 3 squared is 9, minus x will be minus 3 minus 1, and that equals 9 minus 4, which is 5. So my two ordered pairs are 1, negative 1, and 3, 5. And those are 2 points of intersection of the parabola and the line in this case.